Alright, here we are on lesson 19, scale drawings with proportions. So we have the definition of a scale drawing up here again. That's the same thing as yesterday. Then the scale model, though, is a little different. It's a three-dimensional model that is similar to the object it represents. So a drawing is two-dimensional, model is three-dimensional. And then scale gives the proportional relationship between the drawing dimensions and its actual dimensions. So here it says use proportions to make a scale drawing, and what are the two ways that we know how to solve a proportion? So we know that first way is the equivalent ratios. And then the second way is by cross products. And that's what we talked about in the first lesson. So here in example 1, it says that you are making a scale drawing of the rectangular stage in the cafeteria so that you can plan the arrangement of props for the variety show. The stage is 12 meters long and 9 meters wide. In your drawing, 1 centimeter represents 3 meters on the stage. What dimension should you use for the stage in the drawing? Alright, so that part is very important, that 1 centimeter represents 3 meters. Alright, that's our scale that they told us. So remember that X is our original and Y is our scale, and that's what we talked about in the other lesson. So we're still doing Y over X. Alright, and we are going to do centimeters over meters. Alright, and then here's our blank proportion. So, our scale drawing, remember, we decided that we were going to do centimeters on top because that was our scale drawing. We know it was 1 centimeter for 3 meters. And the only thing that we do know other than that is that it's 12 meters long. We're trying to figure out how many centimeters that would be. So, make sure you have this setup written down, because I want you to set it up with the labels, just so we make sure nothing gets lost and nothing gets confused or flipped around. Alright, so now we're just going to solve here, and we can do equivalent ratios here. We know that we multiply by 4 on the bottom, not 3, 4. So we multiply by 4 on the top. So we know that the length here is going to be 4 centimeters. And now if we do the other one for the width, again, we're going to have those centimeters over meters, still our 1 over 3, and then we'll have our width over the actual, which is 9, and here we're going to multiply by 3 on the bottom and on the top, so we get that our width is 3 centimeters. Alright, that first proportion here, that first part of your proportion, is going to be the original. So this part that I've circled, that's always going to be the the scale that they gave you, because that's going to stay the same no matter how many times you have to do it for a given problem. Alright, so that part in the circle is the scale that they gave you. So we're going to do some more examples here. Example 2 on the next page says, in 2003, Cedar Point built the world's first Stratocoaster, top thrill dragster in the fastest and steepest roller coaster in the world. Before building the roller coaster, architects used a scale of 1 foot to 105 feet to design a scale model of the roller coaster. If the model is 4 feet high, how tall is the actual top thrill dragster? So we are always doing Y over X, so scale over the original. And please write this down on the paper so that you get in the habit and it helps you remember. So now if we do our setup here, the scale drawing, we know they're both going to be feet, so you can put feet for both of them. But we know here that in our scale drawing, it was 1 foot per 105 feet in real life. So again, scale over the original, and this part here is the scale. And then we know that the model is 4 feet tall, and we're trying to figure out how tall it actually is. So I'm going to do cross products here. So I get X equals, and when you multiply 4 times 105, you get 420. And if we put a label, it'd be 420 feet. Right? And that's all we have to do for that one. So if we look at the next one, it says that we're finding the scale ratio of the drawing this time. So example 3 says, every few years, the Grand Place in Brussels, Belgium is decorated with a large floral carpet made of begonias. Before making the carpet, designers make detailed scale drawings. Suppose the floral carpet is to be 40 meters wide. That's important. And a designer creates a scale drawing of the carpet that is 20 centimeters wide. Find the drawing scale. So again, we're going to have scale over the original. And then set up your blank proportion here. Alright, and in our scale, we have centimeters on the top, and in our actual, we have meters on the bottom. So, we know that the actual is 40 meters wide, so that's going to go on the bottom here. And then for our scale drawing, it was 20 centimeters. And they're asking us to find the scale. So that means that we're just going to simplify. And if we look here, it's going to be 1 over 2, which means that our scale is 1 centimeter for every 2 meters. Alright, so that would be the scale that they would use for the entire picture then. Alright, we're going to do one more here. It says your mom is thinking about rearranging your living room. She decides to make a scale drawing to make sure all of the furniture fits in the living room. The sofa is 2 meters long. In the scale drawing, the sofa is 2.5 centimeters long. Find the scale of the drawing. So again, we're doing scale over the original. And if we put in our blank proportion here, in the scale drawing we're using centimeters, and in the actual it's meters. And it was 2.5 centimeters in the picture, but it's actually 2 meters long. So if we simplify this, we would get 1.25 over 1. So our scale would be 1.25 centimeters for every 1 meter. Alright, so on the next page, this is a problem about a basketball court, and it gives you the scale drawing and it talks about the actual. And I want you guys to try this page on your own, see what you can do. Here they're asking you about the scale ratio, and remember that was always K equals Y over X, so I'll give you that hint. And then it says to set up a proportion to find the actual width of the court. Right, and your proportion in the end is going to be inches over feet, and this would be your blank proportion. Alright, so I want you guys to go ahead and do this whole page, and then we will go over it in class all together tomorrow.